Okay, today we're trying to do a case study using our ANSYS Workbench software. And the material that I cover today is from a book published by Xiaoling Chen and Yichun Liu, um, Finite Element Modeling and Simulation with ANSYS Workbench. This is one of their case study. So I think this one is also a good example. So let's say we're having a truss bridge that can span long distance and support heavy weights without intermediate support. They are economically to construct and are available in a wide variety of style. And consider the following planar truss and construct of a wooden timber, which can be used in a parallel to form a bridge. So we need to use ANSYS to determine the deflection at each joint of the truss under the given loading condition. So we are going to create a material. The material is called Douglas fir, and modulus Young is given. Modulus Young is 13.1 gigapascal. The Poisson ratio is 0.29, and member cross section is given. The height is 6 cm and width is 6 cm. So later on, we are going to use meter in our ANSYS software. So later on, we will change this one into meter accordingly. So for the truss, the setup will be 1 meter, 1 meter, 1 meter, 1 meter. So we have a 4 meter across of 2 support here, and then the height is 1 meter. So there is 30 kilonewton on this point, 30 kilonewton on this point, and 30 kilonewton at this point. So we're going to simulate and to determine the deflection at each joint. Okay, so how are we going to do it? So at first, you start your workbench and then go and save the projects. So let's say I go and save in project. So I save it as wooden truss project. Save. So once you save, you're going to use our static analysis. It is a static structure. Double click this one. All right, and then name this one as a wooden truss. Now, we will need to generate a new engineering data because the modulus Young and Poisson ratio are new to the workbench. So we need to go to the engineering data here. You right click, and then you edit. So we need to add a new, by default, the software will use structures still, or you can import from the library. So we go and add in a new material here. So the new material, we will be using Douglas fir as what given, right? And then we're going to, after Douglas fir, you press enter, and then we're going to double click isotropic elastic here. Double click. So this window will come out. You need to fill in the modulus, Young modulus here. So as given, it was 1.31 giga 10 power 10. E10 means 10 power 10 Pascal. And then Poisson ratio is 2.9, 0.29. Yeah. Okay. Once we are done, we go back to our project. Just go and click your project here. All right. The next one, we're going to build our geometry. So go to geometry, right click. So my software, I have space clamp geometry and the default design modeler. We're going to use the design modeler in this case. Oh, sorry, yeah. Before we go for design modeler, we need to go to geometry here. we need to select the line properties. Okay, we need to select the lines property. So you will be under here, lines body here. Yeah. So make sure that the lines bodies are selected in this window. Yeah. So make sure the lines body are checked. So some computer don't, by default, this one was not checked. So you need to make sure this one checked. And then you continue with the modeler. So you will take some times to load this one. Okay, now we are in the modeler. So we need to build the model inside here. So before we start, we need to call out the grid. So go stretching and then go setting here. We need to call out the grid here. So click the grid and then click check the 2D, you'll see grid come out, and then check the snaps. Major spacing here, we will have 5 meter. So let's bring the axis to the screen. So by default, you will see a 3D presentation. So you go and click the Z. So you are facing the XY plane. So what mean by major grid spacing here? It will be, you see the solid line, this one. So this point to this point is 5 meter. And then minor steps per major is 5. So you divide each major grid with 5 sections. So means if this one is 0, 0 to here is 1 meter, 2 meter, 3 meter, 4 meter, 5 meter here. All right. So once we done the setting here, so you go to draw. So before you draw, go up to the ribbon here. Make sure the unit you selected is relevant. So in this case, we selected meter here. Yeah. So and then the ruler here you will see in meter also. So we're going to draw the structure of of our model here. Like what you see here, we're going to draw all this line with 1 meter, 1 meter, 1 meter. So we're going to draw 13 line, short line here. So how are we going to do it? So pretty easy. So you go to click the line, and then we're going to start from middle here. So we're going to draw the height is let me see, we extend a little bit. So our structure height is 1 meter. So we draw from here to here, and then we go draw to the close, click and click. Then we draw down and draw. So we draw the structure of our bridge here. So you build the truss structure. Okay, so once you've done all these things, you we will need to generate a body. Yeah. So once you click all this finish, go here, go to the top here, click generate. So you go click modeling. So if you expand this one, you will see stretch one appeared in, if you click stretch one, you'll see in yellow color, right? So meaning there's a stretch there inside the window here. Then we're going to create a line body from, we're going to ask the computer to treat all these line as body. So we're going to turn off the grid for a while. So go to stretching again, go to setting, turn off the grid, just turn off the grid here. All right, then go back to modeling. and we will go to concept, and then lines from, you don't build a body line, line body. So you go to concept, lines from stretches. So you're going to ask you what object to apply, yeah? What object to apply? So click scratch one, and then click apply. So once you click apply, and then you click generate. So once you click generate, you see the software or the modeler will capture. You will change the scratch just now to a body, and the body is called line body here. Yeah. So the next one, you're going to create a cross section to tell the computer to generate a cross section for our structure here. So how you call out the cross structure or set the cross structure? You go to concept. So there's a cross section here. And in our case, we are having a rectangular cross section. So go and select rectangular. So your cross section will appear here in name as rectangular one. So in this case, we are given the height, the B and H diameter, the dimension. So key in B as 0.06 here, H also 0.06 here. So you will see this is our cross section. So once you are done with this one, okay, once you are done with this one, we need to go and click we need to assign this cross section into our body line, our line body here. Click line body. So you see the yellow will come up telling you that there's no cross section selected. So move your mouse here, left click, and go and select rectangular. So now the software have defined all the structure having a cross section of rectangular one in the software now. Okay, now the program is set, so the structure is there. So remember to save your work. So click Save Projects, and then you close the modeler. So you back to the workbench here. The geometry is defined. Now we are going to do our static analysis or structural analysis. All right. So we're going to model. Click the model and then right click, edit, or you can just double click. So the modeler will load and then come out to the screen. So wait for the software to load. So this is the structure that we draw just now. So in order to have a better presentation, again, click the Z here so that we are seeing X, Y, and X and Y plane here. So click Z, so it will facing us. And then we're going to, if you click the model or geometry, you extend, you click the line body here. You see by default, the material was assigned to structural steel. We need to change the material of our object here to the wood properties or wood material. So just now you already key in the material. So go here and drop down. Yeah, go here, click this one, and then you are going to see Douglas fir here. Click Douglas fir to update the software saying that we are using wood as our object here. Yeah. So we're having a Douglas fir as material. Okay, next we're going to apply our boundary condition. We're going to set up constraint for our system here. So what are the boundary condition? So you look back at the diagram here. So these two are the constraint. So we're going to put in constraint is a support here. So we're going to put this in our model here. So how you put into boundary layer, boundary condition there. So you go to static structure here. right click, insert. So there are lots of things you can insert here. You can insert pressure, support, and other forces also. So in this example, going to have a fixed support. Yeah? So click fixed support, and then you're going to click, tell the software where you want to click. So before you click, you go to the top of the ribbon here. There is a filter here that you can click on the vertex, edge, and face. So you're going to use vertex with a point selection. Click this one, and then go here, and then click this one. So you're going to see a green dot there. Then click apply. So you're having a fixed structure on this point. Then after that, we're going to add one more constraint at other end here. So go and repeat the same process. Go to structure, static structure here, insert, fixed support. Then go and click. Make sure the edge selection was selected, or point selection was selected, and then go and click here. So you're going to see another green color come out. Then remember to click the apply. So we have two supports so far in the tree here, support 1 and support 2. All right. Okay, now we have done with the boundary condition. We're going to add the loading. So as you can see from the problem statement here, or the question, you see there are 3 loading here. So we're going to add the 3 loading for 3 forces here, 30 kilonewton. So come here and then go to the static structure again, right click, insert, and then you're going to insert force. So this is the force, insert force. So again, make sure you're selecting a point here, vertex here, and then the first point, click this one, you see green color, and then click apply. And then we're going to define our force as a component. So go down here, change to component. So again, our force is going down. You see the axis here. The positive Y is going up. Our force is going down. So we need to go to Y component here. Key in negative 30,000 kilonewton. 30 kilonewton, yeah. So enter. So you'll see an arrow come out like this. Yeah. So we have done for the first force. Then we're going to add another force in the middle. So insert, repeat the same force, and then go and click the dot here, apply, change to component. Then again, the Y is going down, so negative 30,000, enter. And then we have the second force come out. We need to create one more, insert force. Go and click this point, and then apply, go to component, and then negative 30, enter. So we have 2 support, 3 forces, yeah. So if you click on the static structure here, it will tell you that A and B are fixed structure, and you have 3 forces here, each are going down 30 kilonewtons. So this is what we have in our question here. There are 3 forces and 2 support. Yeah. Okay. After we have all these defined in the question, so we're going to see the simulation, to run the calculation. So we're going to solution here, right click, insert. We're going to see deformation. We're going to see total. All right, and then we're going to okay, then say we see the, let's solve for this one. Yeah, so go to solution, right click, solve. And then you click total deformation. As you can see here, your structure is having some deformation. Yeah, these are the data that are generated by the calculation. So maximum deformation is 0.006 meter, and minimum is 0. So it's no displacement here or no deformation here. Maximum as in here. Okay, now we can find the reaction force also. So how we check the reaction force at 2 point here. So you go to solution, and then insert, and then go to prop. You need to add in a prop to find the force reaction. Yeah. So once we add in the force reaction, then go to solution again. You see a question mark means the software haven't solved it. So you go to solution here, right click, and then evaluate all results. Right click, evaluate all results. Right click, evaluate all results. Okay, so we can set the boundary condition here. So we can have 2. So we need to set the fixed support 1 and 2. So let's see one point here. So let's see what happened to the fixed support here, and then we regenerate the results. So this is the reaction force at left hand side. Okay, you can create another one reaction force. So go here, add another prop, go to reaction force, and then we select the second support here, and then we update. So on the left, how we know the value? You just click this one, and then you roll down. So on the left hand side, the reaction force is at a certain angle. So you have reaction force at x-axis, y-axis, z-axis. So if you do calculation, you find the total is 6 point something, 63 kilonewton at this side. So what about another side? So another side is also 63 point something. It's a symmetry scenario. Okay. Yeah, so basically this is how we run our simulation. So of course you can also generate a report here, right? You can generate your report for your coursework or for your assignment. So you can generate this report, roll down, yeah. So information that important is what are the reaction at point number 2 and point number 1 are here. So of course, you can insert more picture inside this report, or you can just go here and then right click and image to clipboard. Then you paste into your report. Yeah. So you can copy the image by this way. Yeah. All right. So with this, we end our tutorial. So I will end this recording.